Hey.
Would someone edit the YouTube description so we can put the show notes in there once it goes live?
Sure, yeah.
And once we get the link, I will tweet it.
I'll go in there and see.
It says it's streaming live now. Let's see. Copy streaming link.
Can you put the YouTube link into the Slack?
Yeah. Oh.
Okay, it's done.
Okay, well, we're live. I'm going to read this intro. Hello, and welcome to Apropos, a conversation between Clojure programmers that you can join in live on YouTube. We're going to discuss a few Clojure news items and share our opinions on them. Then we'll jump into a REPL, which we do have this week, and code one exercise, one thing. If you're joining us live, feel free to comment in the chat, and we'll try to address the questions. So before I introduce the panel, we have show notes in the YouTube description for this video. So please do jump in, and that's where the chat is. So there you go. All right, so this week we have a full panel. We have a Ray.
Hi.
We have a Mike.
Howdy.
We have a Mia.
Hello.
And we have a me, known as Eric. And let's go into the show notes. Let's look at our topics. First up, ClojureScript release. There was a release in November. Mike, can you tell us a little bit about that?
Yeah, let's see. So I think we talked about some of this last time, but in my mind, the biggest thing in there is this Google Clojure namespace analysis.
Mm-hmm.
Yeah, and that effectively means to you as an end user, if you use any, it's not Google Clojure, if you use any Clojure library, I guess, you now effectively have what the compiler refers to as like analysis metadata, which effectively means you can see doc strings, you can see the arguments, you can do things like you can do dir on a namespace if it's a Clojure namespace and see all the functions that are in there.
So Mike, I was reading the release things, and I was kind of surprised because I always look at the ClojureScript REPL or ClojureScript itself as a compiled language.
Mm-hmm.
So I never think of it as like, oh, I can just do doc strings and get information about anything. Like I just think I just feel like it's a compile. There's a step between like what I write and what gets run in the browser, and there's no bridge between them. But I was surprised. This must have been in for a long time, and I just never knew.
So there is this whole layer on top of it that you've not been aware of.
Yeah,
that's been there. That's basically that kind of understands stuff like when you call a function. You know how you get arity errors. The compiler, as it's compiling, needs to know how many arguments are,
right. The compiler knows, and I understand the compiler has to know that, but like the fact that I'm at the REPL and I'm asking for the docs of some function, like I just don't, it doesn't seem like I should know that.
So all this metadata is kind of kept on the side, if you will,
Okay.
And the compiler and the REPL can consult that metadata. And then, and because of that, it's kind of like it could get disconnected from what's actually in your execution environment. You have like the JavaScript over there, which doesn't have any of this stuff, right? And you may see that like if you disconnect from your REPL and reconnect, some of those functions are actually there, even though you can't get the doc strings for them. And there's a trick to fix that where you can tell it, hey, reanalyze things. And but that's the reason for mentioning that is just to kind of illustrate that they are two separate things, really.
Yeah.
So how is that working?
Like how is it done? Or
is there like a file with all the analysis?
Okay. So let's say you're in the REPL and you do define. You define a function and you give it a doc string or whatnot. That basically it ultimately ends up writing into a file. And it's kept in memory. There's this gigantic map inside the compiler huge, the biggest map I've ever seen, to be honest.
That has everything in that one map.
Yes, everything. Yeah.
More,
as you're compiling,
even than a HTTP request map.
oh man. So as you're compiling, the biggest map you've ever seen is being, manipulated and changed and updated as it like adds functions and yada yada.
So now the new thing is that Google Clojure libraries. So any library that follows the Google Clojure module format now will have metadata in that gigantic analysis hash map.
Exactly. Yeah.
And so we can ask for its doc string. We can the type analysis of ClojureScript will like know the types.
Yeah. So for example, one example of benefit is that it would know like the return type of a function. So if you call a function in the Google Clojure string library, and it knows that it returns a string because it can see that, then the ClojureScript compiler can now take advantage of that and say, hey, I know it's a string, I can do things. All the normal, optimization surrounding type inference kick in. Previously, what we would do is in the standard library, like the Clojure string namespace, for example, those functions at that level would be hinted as returning strings. And in theory, you can remove a lot of those hints now.
Oh, nice.
Just infer them. Yeah.
Huh.
So there's some interesting type inference implications of all this too.
Yeah. I hope that all the Google Clojure stuff is correct.
Yeah, I know. We'll find out if it's not.
We'll find out, or we'll just have weird bugs.
Yeah. So like if you, because the way the ClojureScript compiler works, it's different than in Clojure. It will, a type hint is something that the compiler trusts completely and uses, and it affects the generated code. And if it's wrong, for example, the code that's generated could behave incorrectly.
Yeah.
But I guess ClojureScript is optimized for correct code.
Yes.
Correct
It's highly optimized for absolutely.
Oh no.
Code. Yeah.
No one's ever written bad ClojureScript.
It's never happened. Yeah.
Well,
just saying.
If you write it, it's your fault.
Everything's your fault, Ray.
Yeah.
Including the good code. I guess that's your fault too. Yeah.
You don't get praise for that one, though.
That's cool. And then there's like a bunch of performance improvements. A lot of them have to do with like using type hints better.
Yeah. And there's one thing that I like. It's called intrinsics that are in there now. So like the coolest one, I think it's in this release, is the count function.
Okay.
So we may have talked about this before. I'm getting old. I can't remember what we've talked about. I'm getting to that
This
phase
was
of my life.
pre-release. This was just a preview. Now it's
now it's real. Okay.
Yeah.
So I'm repeating myself, but for good reason. Yeah. But the count function is if you do count on a string, for example, and the compiler knows that it's a string, it can now just emit that string.length.
So how does it do that? Because like I would imagine, I have not looked at the source code, so I'm just gonna say the naive thing that I would imagine, which is that the count function is defined in Clojure, and it says if it's a string, call the dot length, and if it's a seek, like count it, and if it's accountable, then like just return the count. And
so
like
what you're describing works really well for like a macro, where the macro can consult that gigantic hash map and say like, hey, what are my argument types, or what, it has insight into like what's going on. And the macro can do exactly what you're describing. It's like, if it's a string, do this.
So it's emitting different code based on some compile time metadata that's already there.
And that's one way to do it.
Okay.
And that's the way some of the macros work.
But count is a function, right?
Count
it's not
is
a macro.
function. Yeah, exactly. Yeah.
So is there a macro defined alongside the function that's like, hey, if you're try to expand this macro as a macro first, and if it doesn't, then count it as a function?
Yep. As a matter of fact, that was the first patch that I wrote for that one, was actually a count macro, and it worked. But then you have this extra macro now, right? So what we ended up landing in there instead was a thing that's done at the back end of the compiler, or whatever end you want to call that the part that spits out the code.
The back end.
I guess it's the opposite of the front end. Yeah.
It's not spitting.
Yeah,
It's
if it's spitting,
some
it's,
other
uh,
operation
yeah.
that
Oh my
happens
God,
at the
yeah.
back
Emitting
end.
code. It's emitting code. Yeah. It's emitting JavaScript.
Emitting is nice, yeah.
Yeah.
Emitter.
So that's where
Emitting, yeah.
that's
Rhymes
where
with emitter, yeah.
and Roman Lutikov, he's been doing lots of these intrinsics. And the cool thing is you can say an intrinsic is basically when the compiler says, hey, I know a faster way to do this thing that you're doing. And it's intrinsic into the compiler. It says, hey, I see this thing
it's
you're
in the
doing here.
compiler.
It's like the compiler knows this specific code construct that you've written. It's like, let me pluck that out and like it's almost a pattern matching thing. Let me put in something else instead.
So it's not a macro. It's not something that we could access ourselves in our
Right.
code.
Exactly.
So as
It's like
used
hidden
like
inside
end
there.
users of the language, it
Yep.
is part of the compiler. I see.
Yeah. As far as you know, you're still calling the count function. It's just the emitted code no longer does that.
Right.
It
Yeah. It would be
basically
cool
accesses-
if it was some like feature that's like,
controllable or influenceable or
yeah, just like
Yeah, yeah.
like a macro is a way
Yeah,
to
yeah.
extend the compiler.
I
you
think
know,
I think Scala has some of that built into it.
Yeah,
Right.
just a way to say like, look, try this macro first, and if it doesn't, throw an exception like I can't handle this,
Yeah.
and in which case you would use the function of the same name. I don't know.
Yeah. Yeah.
Seems
But isn't this a bit like kind of, in the Java world, what hotspot does, or, it kind of, rewrites your code.
Mhm.
So.
And I think there
you
are
don't
actually
know what really is going on underneath it, because it's kind of
Right.
doing all these fancy tricks as you go along and rewriting it and then rewriting it again and rewriting it again. So
yeah, at a certain
Yeah,
point you
some-
just let go and let it do it. Yeah.
yeah.
And there are intrinsics in Java. It'll see like, hey, you're
Mhm.
doing something. I don't know, and I can't name any if you ask me to, but
Mhm.
yeah.
surrounding some like big integers maybe or something. There's some intrinsics surrounding some of that stuff, I think.
Yeah,
Yeah.
it probably tries to detect that you need like boxing and or you don't really need a box here and things like that. That it could probably do. I'm just trying to figure out like whether I like it aesthetically.
Yeah.
Like there's
So yeah.
it just seems like you're making the compiler more complex.
Yeah.
Um,
Do you
and,
like the macro form better? Or?
I like the
Or-
idea that the
yeah.
complexity is pushed to the end user, right?
Hmm.
So, and then I'm wondering like what
What do you mean it's
the
pushed to the end user?
So like in Clojure, you can do the inline thing. Maybe that's what you're thinking of. Like you as a user can say, for this thing, do this.
yeah, that like how Clojure, the compiler is, it has a certain level of amount of complexity in it, but then it's saying we're just going to push a lot of that into macros.
Oh, right.
Mhm.
Okay, I see.
And so we only have to know how to compile this smaller language, and then the macros take care of other language. But then the macros are something you can use as well.
Yeah.
So yes, Clojure Core has a bunch of macros that you use all the time, and but
Yeah.
but you're also able to access that.
Yeah, this count thing is kind of extra linguistic or whatever. It's down in the compiler.
Yeah,
It's leveraging the JavaScript itself, isn't it? Like it's not actually.
So like in terms of like the actual optimization that you get out
Yeah.
of this in the end. Yeah. So,
Yeah.
okay. So if you back up and say like, why, what is this all
Yeah.
about? If you today or previously, unless if you're still using the old compiler, if you do count on a string, you get this, this function call to the count function. And inside of there is a cond branch, I think a bunch of, it checks different types.
right. Like
and
nil is 0 and
Yeah.
string, you have to do dot length. If it's
Yep.
an array, you do
Yeah.
dot length, and yeah.
Exactly. Every time you call the count function
Right.
for like, so if the compiler knows it's a string, you feel compelled to optimize that, right? You want to just say call length already for me. I know it's a string up front. Don't keep checking over and over again that it's, that it's nil or it's a string. And that's basically if you have type inference and statically that it is a string and it can't be anything else.
Right. And so this is nice because before I might say, I need my code to be faster. I'm going to optimize it. So I'm going to inline all these .length calls and because I know it's strings or arrays.
Yeah.
But now the compiler does it for me. So all I have to do is say A is a string. Work your compiler magic.
Yeah. And or just hope that it infers that it's a string, right?
Mm-hmm. Right.
And unless you really, but you're right, Eric. Like if
I profile it and I say
you got a tight loop or whatever, and it's like looping through, and you're like, you could hint it and say, hey, this is a string.
Good luck profiling the JavaScript. Well,
it was a theoretical profile.
Well, I think Chrome has tools like that. But,
And just speaking of not liking things aesthetically, like
yeah.
Again, it's one of these things to some extent that it's always a balance, I think. I mean, I don't know enough about what the metrics were that you and Roman calculated in terms of, what the underlying JavaScript virtual machines do for that, because, they're not dumb. So, they've had a lot of money put in them as well. So did you notice in some like micro benchmarks or some other benchmarks that it made a difference?
Yeah, I think for this one, it was anywhere between 10% faster and 6,300%.
Wow. Okay.
Because you can so we did measure. Yeah. And it all depends on context and where you're using this function.
Sure.
Yeah.
Right.
That depends on the VM. Yeah.
Yeah. That's really interesting because you would think that by now the JavaScript engines would hotspot this and say, well, it's always been a string. Let's make that the main branch. And
yeah.
And
so what happens, Eric, is that a lot of the faster engines do in fact do things like that. And when you make an optimization along these lines, oftentimes they don't benefit very much. Yeah. And it's the more immature engines that benefit a lot from it because you're kind of helping them out in a place that they just haven't figured out yet. Yeah.
Right.
Spider Monkey, I think, is the main one that falls into that category.
I guess it, like you say, I guess it means that like you can run it on hot JavaScript runtimes that aren't super optimized. Because we're kind of going off the topic a little bit, but still on topic is that you've been working on some embedded JavaScript and embedded JavaScript runtimes and stuff like that. I don't know if we're happy to swap over to that topic or. Are we done with the ClojureScript release?
I'd love to hear more about this embedded
JavaScript.
JavaScript.
I'd love to.
Let's talk about this.
Oh, okay. Yeah. So what Ray's alluding to is there's a engine called Esperino, and it can execute JavaScript. Yeah, I know. Isn't that great?
From Arduino.
You like that name? Yeah, I don't like it either. But whatever. Don't judge an engine by its name, I guess. Esperino. But so it basically it's targeting running on these little microchips or system on a chip kind of things where you have very little RAM, so much RAM that you can't even afford to compile the JavaScript into machine representation. You just have to interpret it.
Right.
And that those environments, as Ray said, those are very immature in terms of there is no optimization. It's just interpreting what you give it, in a sense.
Mm-hmm.
So in that case, you really want your JavaScript to be optimal.
Tight. Yeah. It just seems it seems not Lispy. Let me just put it that way. So, that like your compiler's getting bigger. It's starting to know more and more about individual functions and what.
Yes. It's
like
unholy. You don't like it.
Yeah, I don't like it.
It's a Lisp machine. That's what he's doing.
So ClojureScript is definitely like when you're in a REPL, it's very Lispy and very dynamic and then you go to deliver and it commits every sin known to mankind to make it fast. And
come on,
John McCarthy's turning over and like, what have you done? No. Not Lisp anymore.
The SICP video says exactly this, they're cool about this,
compiling Lisp.
That's what you want everything to be dynamic in the REPL, and then you want to compile it and run it. So it's not anti-Lisp. It's perfectly fine.
Well, it's not that it gets compiled away. That's not what my problem is. My problem is that the compiler is going to be getting more and more knowledge of these functions like by name, like if we call the count function, we replace it with a dot length, and if we call this function, and it's like, but this is a function defined in
core
Clojure. Like how, and now we're redefining it to mean something else when we're doing a compilation step for these special cases. And that's why, like, aesthetically, it would be more appealing to me if there was some mechanism that was, that was also exposed, so that you wouldn't have to make the compiler more complicated. You would and know more about it. You could say, look, there's two definitions of count. One that's a function that's dynamic and whatever, and one that's a macro that will actually do this inlining. Yeah.
So a very clean thing that's very close to what you're describing is if you are writing a macro and you happen to want to know, like, hey, compiler, do you know have you inferred the types of my arguments? Can the macro then ask at expansion time, do you know the types? Is it, there is no clean way right now to do that. Like if you want to write a macro that does that, you have to delve into so like you can't even add that to the ClojureScript compiler without it being like non-Clojure anymore, right? There's no standard way of defining how do you access inferred types in a way,
Right.
Rich could add that to it and say, like, here's the way,
It's interesting because there is some stuff that's there in a macro, like these dynamic vars that you have access to. Be interesting.
You control through the env.
Maybe I don't know if this is like just me kind of smoking something about a bit of wine. So, but maybe it's all this thinking about like spec becoming more programmable in spec 2. Maybe it's Clojure itself, or in that sense, maybe that could also inspire Clojure to be more programmable in the sense that you're alluding to.
Yeah,
why not? Could be a nice next level thing, couldn't it?
That's what I think you have to do. Is you just have to do it and add these things, and then learn. Like, I don't like it. There's a cleaner way to do it.
Yeah. Right. No, that's cool. And ClojureScript seems to have enough releases that. You're doing all this learning, and like one day you might have a big release. It's like, okay, we got this new thing. We're moving all these micro optimizations out into it, one at a time as we have time. It's cool.
So back to the Arduino, Esprino.
Yeah.
Oh, that stuff. Yeah.
Yeah.
You want to know more about it?
Yeah. So
how much RAM does this thing have?
Okay. So like Arduinos typically have like a few kilobytes of RAM, right? You're talking about kilobytes. And then a normal computer has like gigabytes of RAM. And there's a ESP32 chip that's like in between that has megabytes of RAM.
Huh.
And that is like in this weird sweet spot where it is a microcontroller in the sense that it you boot the thing and it starts up in like a few seconds and it's running your JavaScript or your ClojureScript, like right away. Whereas like a Raspberry Pi could take like half a minute.
Right. It's got to boot a whole Linux or something.
Yeah. So it's got that advantage, and it's got enough memory to actually like have something as big as ClojureScript in it, Whereas an Arduino, it's like a few kilobytes of RAM. You kind of have to resort to programming in something like C at that point, So these devices are starting to become a thing now,
Yeah.
But a thing where?
Well, you can buy one for like $4.
Oh.
And isn't it like your size of your thumbnail or something?
Yeah. I have one lying around here somewhere.
And I think it's like, where is it happening? It's happening in
I'll go grab one.
Industrial IoT environments and, all kinds of spaces where you'd have like microcontrollers.
There's
machines,
one. There's a couple
inside of machines.
So where's the chip? Okay.
It's inside this can here, this RF shield. There's another RF shield. And these things have like inside there's like Wi-Fi and everything too, and Bluetooth, and like all this stuff's on this little chip. $4.
And you're making AJAX requests?
You can
with that thing? That's pretty cool.
You could do, yeah. So it's kind of constrained in terms of memory, and it's kind of slow.
Yeah,
but it's
enough. Yeah,
I know. That thing boots in a few seconds. So
yeah,
like if certain use cases where you want to put this inside of something, or
So you just boot right to like a JavaScript interpreter.
Exactly. Yeah. You remember those basic computers you had in the 70s and you flipped them on?
Yeah. And
There
a
was 80s,
prompt would be,
Commodores.
you'd be
Yeah,
like, okay,
exact same thing.
print
Yeah.
my Eric is cool, go
Yes.
to 10, and then it
Yes.
would just, yeah.
Yep.
Yes, I
This is
remember
what that
those
is. It's
from the
basically
70s.
JavaScript's in the ROM, basically. Yeah.
Yeah. I think it does
They
fire up
were
all
s-
of the device drivers first, doesn't it? It does fire up all the radios and everything first.
Yeah. Yeah. In the first few milliseconds, if you like time it.
I have a friend who's really into those. There's a bunch of Lisps that run on them.
Yeah.
There's all
Little schemes and little Lisps.
Yeah.
Well,
But
now
this is the kind of
ClojureScript.
thing-
That's cool. Wait, does it work? Does ClojureScript work on it?
Yes.
And you can have a REPL into it?
I've got a part of a REPL. Yeah.
Part of a
yeah.
REPL into it?
Yeah. So the big problem that I want to figure out
Can't
is
close the parens. That's the problem. Is the part where, yeah.
friggin' friends. Yeah. The challenge is like to have a REPL, you kind of need all of ClojureScript's core library available.
Right.
Because you might call count. And therefore it needs to be there, right? But you can play games, then you could say, well, maybe not everything needs to be there. Maybe you can lazily load pieces. So
what if you just have the compiler running on your machine and then it sends the JavaScript over?
Yeah, that's definitely part of the game. Yeah, the compiler is definitely not running on the chip.
Okay.
Yeah, it's not like a self-hosted thing. Yeah.
Okay.
Right.
So what I'm referring to is the target environment that your
you kind of need to know, what have I already sent over? Because is count over there already? Because that one kind of calls a couple other things. And like,
and after a while, if you call enough of those things, you end up with all of it there, right? And you're like, oh man, too much RAM being used. Yes. Because
garbage collect.
Yeah.
Start over. Whatever.
Yeah.
But it's weird to think of count as garbage.
Who needs it?
although you're making a good case, you know.
You can turn it to a .length call and just get rid of it. Yeah. But anyway, yeah, it's a new. This
would be
a
cool if you thought of, I don't know, like a subset of ClojureScript. Like, let's say you jettison some big things like the immutable data structures, right? You're like, look, we're in a constrained environment.
Yeah.
We don't want to tax the garbage collector too much. It's not even that good of a garbage collector on this version of JavaScript. What could we do with, mutable variables and just the built-in JavaScript data structures?
Yeah.
You could do some cool stuff.
Yeah, so I actually tried that. And so if you do an advanced build, ClojureScript tends to be around 100K, the output that you typically get. Because of all these, all the data structures. You get the transitive closure of anything you statically could have called, right?
Right.
In fact, you aren't calling it, but you get that. And that's what, but if you jettison the like persistent hash map and all that kind of stuff, that'll save you about a quarter of that.
Wow.
Oh, okay.
Then you could just, you could write it in a simplified subset, like you're thinking. Or maybe just use a kind of simpler copy and write implementation of those things. That kind of has the same interface, but there's all types of things you could do. Yeah.
Okay, so you mentioned advanced compilation, and it made me think of something. Just back to the compiler improvements that we talked about before. Do these optimizations, like replacing count with .length, does that happen with no optimizations?
Yes.
Google Clojure
optimizations in the REPL.
optimizations?
Yeah, it happens while you're in the REPL. Yeah.
Okay, gotcha.
Yeah.
Okay, that was my question. I wouldn't want, because I would feel really weird about it being different in advanced versus no optimizations, because then it seems like you would miss bugs during development. Yeah.
So one thing that's common with intrinsics, even like in C++ compilers or whatever, you typically can turn off intrinsics because if you get an intrinsic wrong, it could lead to a bug, right?
Right.
It's an optimization, to be honest, So that probably needs to be added to the ClojureScript compilers.
Okay, so you can't do that yet.
Can't do that yet. You have no choice but to live with them right now.
You have to go fast.
You have to, yeah.
Gotta go
it
fast.
makes sense. Yeah, that makes sense to be able to turn them off and say like, hey, please don't do that.
Cool. I think it's 39 past the hour.
Yeah.
So we should do some REPL.
I agree.
REPL time.
REPL time.
Let me see if I can.
Who's going to share?
I will. Let's see. Let me
And then
share.
I don't think we've actually talked about conj yet.
No, we
So
right.
maybe we can do that next time. Because
So I
Ray
think
was
I'm
there,
sure-
Do you
right?
want to talk about it?
No,
We
I wasn't
can.
there. No,
I was there.
Right.
I was there.
Eric was there. Okay.
We could. I mean, I don't know what to say about it. It was the conj. It was a Clojure conference.
Anything exciting?
No, I wouldn't say anything excited me. I mean, okay. Personally, I was very happy to be there. I had missed other Clojurists, and it was nice to talk to them. And I met a lot of people that I knew online, that kind of thing. So it was very nice for that.
But that's always good. Yeah.
Yeah, there was no like major talk that like shook the foundations of the internet or anything like that, like the hacker news, apocalypse.
Well, I guess there's not really anything particularly big dropping. So.
Right.
Yeah,
we're still waiting for the
which
drop.
is itself a bit of isn't that like what should we say, kind of notable by its absence, the fact that
that Rich Hickey didn't give a talk.
Well, the fact that they're talking about Spec 2 not being in 1.11 and everything is kind of like drifting off a little bit.
Maybe something's going on.
Yeah.
They're slowing down.
Well, maybe they want to get it perfect because it's not Spec 2 alpha. I mean, you can't.
You really think it's not going to be Spec 2 alpha?
Might not be Spec 2. Spec 2 Omega. I don't know.
Beta. It's starting
the
beta
definitive
now.
Spec 2. Spec 2.final
Canonical edition.
.jpg. But,
yeah, I mean, I part of me is like, no, it's good. Rich Hickey didn't give a talk. I know talks take a long time, and he probably had more time to work on the stuff that we're waiting for. So, there was. I think that all the major ideas have been hashed out, so he doesn't need to talk about them. I mean, that was my impression. It's just like, let him do the work we're waiting for.
Well, it's not conference-driven development,
Yeah,
like,
exactly. Like last year, he had the maybe not talk, which was very much about the ideas of spec and explaining why it needs a 2 before even 1 is out of alpha, which was, I think very welcome.
Yeah.
But this year, I think it just seems like the absence means, I mean, I'm just speculating, right? But it just means that there's nothing surprising.
Yeah. Well, cool.
I
Very jealous.
I think the truth is that software is pretty hard. It's harder than you think,
Don't get it right the first time.
Yeah, it's pretty easy to get something out, but to get something right is not easy. Yeah.
Yep. There was a cool thing using spec that I was pretty excited about. It was a talk where it would tell you whether your new spec was violating the contract of the old spec.
Oh, nice.
Right. So,
That's the dream,
the idea of like, is this growing? Is this, growth
Accreting,
by the Rich Hickey? Yeah. Is it accreting, new possible inputs and
so someone wrote a library for that,
restricting the outputs? Yeah. Someone wrote, using the generative testing stuff, they can generate inputs and see if the new thing can still accept all the inputs that the old one could accept, and that it doesn't generate new things that the old one didn't generate, right? So are you expanding the contract or contracting it? And the other cool thing was that it works because it's just using the generators, it works between spec 1 and spec 2. So you can know whether your spec 2 was done correctly in terms of translating from are you covering the same inputs?
So this could eliminate a lot of the pain that is going to happen for people who are moving over from Spec 1.
It really could.
That's great.
It can give you automated tests to know that your Spec 2 translating from Spec 1 to Spec 2 wasn't, didn't have a problem. So that's cool.
That's great. Yeah, that's going to be really necessary.
Yeah.
All
so
right,
I was
REPL.
very excited about that. Yeah, let's go to the REPL.
REPL.
Okay, REPL.
And do you think could we get a link to that?
Yeah, I'll put that in the notes.
All right, cool.
Okay, I am sharing the REPL.
I still need to give you my SSH key. I'm not in the REPL today. Switched computers again.
You got to stick with the same computer. Never change.
I've
Never
changed
switch
as well,
jobs.
actually.
Append only
I'm,
computers.
Yeah.
I'm running Linux full time now.
Oh, wow.
Ooh. That's interesting.
Yeah.
So Eric, you're in the REPL, right?
I was. Let me check. Yes, I am. Mm-hmm.
Okay. So it's you and me, I guess.
Okay.
Or is Ray in there as
Is
well?
it a battle? Is it like?
No, I need to do a Mia and add my SSH key as well because I've moved from Mac to Linux.
And you lost your SSH key?
Lost it is too strong, Just
People
haven't created a
can't.
new one,
Oh, you haven't put it in that folder yet. I got you.
By the way, I think that the show notes for the current video are actually the show notes for last week.
Oh, really?
Oh.
Oops. Yes, they are.
I'm gonna share this again in the Slack. So whoever did that,
because the problem definition was in the show notes.
Yeah, and I was like, oh, we should share them. And Josh Riley wants a link to the microcontroller as well.
Oh, this is the wrong one. Okay, let's start in the. Oh, well, no, I'm gonna change the show note link. We should do that because that has the problem description. We need to do it now. Okay, let me put it in there.
Mihail says, I found a fun way to crash the REPL. Maybe try it. Please tell us how to crash the REPL.
Let's see. I think I saw him talking about that before.
Okay, so everyone who's listening, I just changed the show notes link. Sorry about that. But now it should work and you should be able to read the description of the exercise that we're about to do. What's so funny?
The way to crash the REPL.
Okay, I'll try it and see.
Exit REPL.
Okay, so
symbol.
Let's see. Okay, and then we call this function and watch it disappear.
That should be.
Okay, before we do it, let's see if we can guess why this works. Exit REPL.
Well, first of all, is exit REPL already? No, it's not.
So it's trying to convert a string into a random UUID into a string into a symbol, and then make the current NS be that crazy symbol.
Yeah, I mean,
why would that make it go away?
Okay, well,
I don't see it.
Because if it doesn't have a real.
Okay.
Forget how the random UID generator works.
Right.
So let's just try it.
Uh-huh.
Okay.
So
yeah.
Anything special then? Okay.
So
you don't need to go that far, Mike.
No namespace ABC found, so I'm just gonna die.
Wow.
Well, but let's see if we get a different error with exit REPL.
Okay. See if it's more exciting.
Yeah.
All right.
No.
No.
No, same thing.
Okay, cool.
Okay, well,
thank you.
That is interesting. That
yeah.
it
just
goodbye.
crashes. You would think it wouldn't crash.
Right, you'd think it would say no.
Is it because of the set? So NS is some sort of global variable. Is that the problem essentially?
And then the REPL code probably tries to switch to that.
Right, yeah.
Let's see.
Whereas if you say in ns blah,
Okay.
then it should give you a different error message, I think.
Blah. Okay.
Right.
It doesn't
just
die.
to look it up first.
Creates
It
it.
actually, it just,
It
yeah, it
creates
just
it,
makes the
yeah.
namespace.
That's what
It
it's supposed
is,
to do.
you would expect you would expect set to create that namespace.
But you're just setting a dynamic var to some value. And
But isn't that
the
what
REPL
in NS
trusts
does?
that, huh?
Isn't that
Oh,
what
in
in
NS.
does?
In NS, I can't even say that. In-NS is like a REPL special, right? That will create. I don't know if it is in Clojure. Maybe
Right. It
just-
probably tries to look it up. If it doesn't find it, then it makes one. And then it sets the star
Yeah, it's a
NS
REPL
to the.
special, yeah.
Well, let me go back to user because I'm in blah. Okay.
Creating it if needed, right? So it's got a conditional on there to create it.
Okay. Whereas
Whereas
set would not.
is just bam, just do it. Yeah.
So rude that it exits for you.
It's optimized for correct closure.
Jesus.
Are we ever gonna live that down? Oh my goodness.
I want mugs. I want mugs for the whole team. Optimized for correct code.
We need to start selling T-shirts.
Optimized
for correct
key.
closure. Yeah.
It's
Okay. We have an actual problem we're going to try to solve.
Right.
So here's the exercise. You can read it in the show notes. You might have to reload if you had the old link. Okay. Given a 16-bit number, I want to generate the bytes associated with its little endian representation. Maybe that's too easy if you use a hosty API, but seems like you should be able to pull it off. This is all Mike's description. I hadn't read that second sentence. Okay, so the example is if you give it this byte, or the 16-bit number, 96,503, then it should generate 4 bytes for your 16-bit number, and here they are in hex. Yeah.
put them in
So
there. That's what we wanted to do.
That's what we wanted to output.
And note that if you evaluate this is kind of like maybe background information.
Oh.
So that is
That's neat.
So can you just do something like totally hacky and print it to printf with into hex instead of into decimal? Sorry, that's my first thought that since the reader can read that, why shouldn't the printer be able to print it?
Okay, so now this is good. I haven't done this in a while. Is it something like that, maybe?
Yeah.
Wait, no, it's format, right?
Yeah, format. Yeah,
format.
that's right.
And then the number of choice. Yeah. Oh, this feels so sinful though. Let's see. All right.
So yeah, you need to put
a left pad.
But you can do like %08.
Not left pad.
%08. There you go. No,
Okay.
after the X. Oh.
Oh.
Oh,
No, that did it. Okay.
Okay. And then
You can put a 0x in front of it.
I need to reverse it. We're backwards still.
Oh, okay.
So I was going to partition it. Can we partition it by 2s? I'm just trying to break it up into little nibbles, if you will. Nibbles. And then reverse them. This is getting messy though. It's getting close. Close enough for government work. F778.
Yeah, it works.
You get 4 nibbles, and then you could exercise for the reader to finish that off.
Just map string over it, or map. What would you do? Map apply string.
Map apply string to it, because yeah. That. For the bit. Yeah, getting there.
Extra.
And then join it.
Or just join. Yeah.
Yeah.
Sure.
I think that join is a string function though.
Yeah, I'd have to load that namespace.
Yeah.
There, that could be an intrinsic for you if that's faster. But that's pretty much getting there. Yeah. Oh, we wanted actually the 4 bytes. I'm sorry. I didn't mean to do that. We didn't want to go that far, right? We wanted to convert those into bytes. Then you got to read them.
Put a 0x in front of them.
Yeah. Yep. I could do that. I don't like this string stuff though.
No, it's probably not what you're looking for with bit manipulation through
It's
strings.
a whole bunch of. There's a bunch of this stuff, right?
Yeah.
Bit operators. We could bit shift around. Yeah. Okay.
Bit
shift
set,
right.
Bit
I did some of this a while
shift
ago
left.
to implement an ASN1 compiler.
Oh.
Okay, so you're all over this
Fucking
then.
horrible.
So what if you do something like, can you cast to a short so that you can get just the first byte
Okay.
or first 2 bytes? I'm sorry.
Yeah.
Or just the first byte.
But
Cast
then
it to a byte.
Do you know that it's a okay?
Cast it to byte. That will truncate it, right?
Okay. Cast this number to byte.
Yeah, 96503.
And we get.
What does that do?
Oh,
Out
you
of
can't do that.
range. Okay.
You can bit and it. Right. This will give Ray the heebie-jeebies.
Okay, gives you 247 as a long though, right? What's the type there?
Yeah, that's wrong. Well, you could then. Can you cast that to a byte?
How do you
Still gonna be-
cast? Yeah, you could cast it. 247 doesn't fit in a byte?
Because it's too big.
Oh, because it's
'Cause we're in
assigned
Java.
byte.
9 bytes.
Oh.
Java, assigned bytes. Okay.
Maybe we should just code this and see.
I man, this is bringing back some memories using bytes in Java, because you do have to represent them as something bigger than an actual byte for that reason.
So we're stuck with that and turning that thing into a byte.
How does the reader macro do it?
How does the reader macro do it?
Yeah.
Like, how do we get a byte?
How do you mean if it reads 0x?
That's a character. Sorry, I misunderstood. So, how do you even make a byte in Clojure?
I don't know.
Have you ever done this before? Have you ever made a byte?
Make a byte in Clojure. I'd never done this.
Well, you can say get bytes from a string, for example, and you can just say the first one, and you can see.
You can do a byte array, which will create an array of bytes.
Oh yeah, okay.
You just do you do byte array size or seek. So if you just do like byte array 10, you would get an array of 10 bytes.
Well, but so does that actually give you
That sounds useful.
bytes? So like if you do
first of
first of the byte array, what does that give you? What type? Should give you 1, right? But what's the type?
Okay. You ready?
Yep.
Let's see. What do we get?
Oh,
A
byte.
byte! Woo! We have a
We made a
byte. you can't put 255 in there.
Yeah. Okay. What was it? 247?
Yeah.
It's gonna say
And
no.
Wait, you need to put yeah.
And we get rid of some of this. It'll be unhappy with that.
Oh.
Wait.
Wait.
First
This is our. Yeah. Okay. No, that's right.
Well, but
Actually-
it's a byte. It's right. It's right. It's
That's
the
the
right
right answer.
bits. It's the right bits.
It's overflowed, yeah.
But that's what I wanted. That's what
That's what you wanted? Okay.
Yes. Yeah, because it's the. Yeah, it's a byte.
So to make a single byte, you make an array with it in it, and then you take the first one out. But you need 4 bytes.
What? Yeah. So,
So it's
that's
good to
pretty-
have it in a
Oh.
byte array.
Yeah. So byte array is good.
You can also do bytes on a collection, and it will cast them to bytes.
Oh, okay. That's nice to know.
This is a cool one.
Yeah.
Cast to bytes, but does that do the same cast we tried to do, where it says, "Hey, 247
Let's
can't
find
be."
Okay, so bytes on. You're thinking on this thing?
On two. No, just on on that. Yeah.
Ooh,
Yeah.
no.
Persistent vector cannot
That's
be.
weird.
I would
maybe
figure you
have
could
to
do it to
on a
this.
binary.
No, it probably casts. Well, byte star.
No.
Yeah, I don't know what
I mean,
that
it's
function does.
this little
It's a
thing here.
cast.
This little
That means a byte array.
right. So it already is.
Interesting. So the difference between bytes and byte array. Bytes is used for referring to the bytes.class from Java. So it's pretty much only used for interop.
And byte array gives you a Java array
Yep.
of type byte.
Yeah. So you can do bytes on a byte array.
I see.
But
Okay.
But you've already got them. It's the same thing. So.
Right.
So knowing this.
Oh, I've got to go. I've got a
it's
meeting.
time.
Bye, everyone.
Bye,
Okay.
Mia.
Later on.
See you, Mia.
I think this kind of hooks it together. Like you could do something where you say byte array, and then you could say bit shift right.
Right.
That whole pattern.
Right.
Bit shift right.
And you do an and then you bit shift, and you do an and, you bit shift again. You do.
Let's see if we wanted to do like 8 bits to the right.
Yeah.
And then yeah, it
and
get kind of heinous looking.
You got to and it with
really
bit and it with the
horrible.
FF.
Yes.
There you go.
That dude would give you one of them.
Now look at it. What's the first out of
Wait,
that?
did I do something wrong?
No, you got a byte array out.
Oh, okay. So
you could seek on it, something like that.
Okay. Yeah. I'm
120. Is that one of them?
Let's see. Our numbers were F7 was one of them.
Wait.
78.
78. Is that 120? Yeah. Yay. We got one of them out.
Yeah. So you could just do it all for.
Right. You start 0, 4, 8.
Replace this with a thing.
And 12. No. Am I doing it right? Wait, I don't. But see, you need to do it inside of that byte array.
You need to produce a sequence.
No, I think it's okay. Do a map inside of that.
Oh, yeah. Okay. You're right. Yeah. All right. Here we go.
Map that over the numbers, whatever. You could cheat. 0, 8.
Right. You need to put the pound sign in front of your.
Thank you. Yeah, that would be really unhappy. Yeah. And maybe the other direction. I might have, because we're doing the little Indian, right?
Right. And then are they bytes? Like, what is the type that's given you?
Oh no!
So you gotta take that map and call byte array on it.
Yep.
Yeah.
Okay, it's getting there.
Byte array.
On that dude.
And now call seek on that. Okay, yeah.
Byte,
there you
byte.
go.
Whoa.
Yay! Yay!
That was painful. But it's probably correct.
Just remind me though. What's the how do I know if it's big endian or little endianness?
Oh, okay. So this ordering here is where you have well, this is not even represented as a sequence of bytes, right? But we said the answer is actually looks like this order. F7. So the first thing that you get is the least significant byte. That's little.
Right. You want the least significant thing in the first position.
Mm-hmm.
That's little endian.
Right.
And big endian is the most significant in the first position.
That's it.
So it'd be
I've forgotten what the difference.
The other order, starting with series.
I gotcha. Cool. And what are you going to do with all these bytes you got here?
So remember we were talking about Esperino and the ESP32.
Mm-hmm.
So there's a thing that you can where you can flash a file to it, right? You can basically make a binary of the JavaScript that you want to put on it to load upon boot. Mm-hmm. And the very first thing in that file needs to be the link to that JavaScript. in this order
and
that format. So it's kind of like, yeah, it's like it has its own way of understanding bytes, and they're little Indian. And
cool.
so that's the motivation for this kind of a problem. Yeah.
Very nice. Very nice. Okay, guys, I've got to do a Mia and get out of here.
Yeah, I have to run too. All right. Thank you so much. If you like the show, please subscribe and you'll be notified when new live Hangouts are happening. And you'll also get the link to the YouTube video, which unfortunately we have not figured out how to pre-generate the link. Mm-hmm. You have to do it like, you know, as we go live. So
I could convert it to bytes for you, but we
we'll get there.
Yeah, well, maybe we will, maybe we won't. We might have to continue with this, but that is the best way to be notified. People who are subscribed know before we know the link. So there you go. Thank you so much, and see you later.
Hasta la vista.